Καλησπέρα. Σας ευχαριστώ πολύ για την ευκαιρία που μας δίνετε να παρουσιάσουμε την εταιρεία μας. Πιστεύουμε ότι αυτά που θα σας πούμε σήμερα θα τα βρείτε πολύ ενδιαφέροντα. Η εταιρεία η Vector Technologies ιδρύθηκε το 2006 σαν ένας σημαντικός προμηθευτής οργάνων και μετρητικών συστημάτων στον χώρο των τηλεπικοινωνιών και όχι μόνο. Δραστηριοποιείται σε όλα τα Βαλκάνια, Αλβανία, Βουλγαρία, Ρουμανία, Ελλάδα και Κύπρο. Έχουμε μεγάλη παρουσία στους telecom operators αλλά και στους κατασκευαστές. Αντιπροσωπεύουμε την εταιρεία Keysight, το κομμάτι των wireless, εδώ και πάρα πολλά χρόνια, από τότε που πριν εξαγοράσει την αρχική εταιρεία που αντιπροσωπεύουμε, την Renaud Technologies, που ίσως πολύ γνωρίζετε, η οποία κατόπιν αγοράστηκε από μια εταιρεία, την Anite, και κατ' επέκταση αυτή η εταιρεία αγοράστηκε από την Keysight Technologies πριν μερικά χρόνια. Και εμείς στην Ελλάδα και στη Ρουμανία και στα Βαλκάνια γενικότερα αντιπροσωπεύουμε το κομμάτι των wireless, το οποίο έχει να κάνει με drive test συστήματα, benchmarking και γενικά testing συστήματα και όχι μόνο στο 5G αλλά και στο 4G, 3G και ούτω καθεξής. Το λόγο όμως θα ήθελα να δώσω στο συνεργάτη μας, το Renaud, ο οποίος, όπως είπε και ο Βλάσης, είναι ο telecom specialist, για να μας μιλήσει για τα testing challenges στο 5G. Σε ευχαριστώ και πάλι, Βλάση, και τον κύριο Νόστη για αυτή την ευκαιρία που μας δώσατε. So, Renaud, I think you can start with and challenge us with the testing challenges of the 5G.
Great. Thank you, Pános, for the introduction. Do you see my screen?
Yes, we can see it.
Excellent. So I will start the presentation mode, so then it's going to be easier for us to see everything. Great. So yes, during this presentation, we're going to try to go through some of the key factors of 5G, and I'm going to try to make you understand some of the associated testing challenges, at least some. I got only an hour, so I won't be able to do everything around that, but at least you will see some of the key challenges that will push you to have another strategy compared to what you used to do with 4G. 5G is totally different, and you're going to have to consider some other approaches in order to test what's going on the network. And I will show you why actually this technical complexity will push you to have some other test campaign on your network or on your devices. So 5G, and I'm sure you're familiar with this slide. I won't go through that for too long, but basically it was in the phase research until, let's say, 2015, and some of the investment, and actually the Keysight investment, and this is, and I think Pános covered that in the introduction, the investment of Keysight at that point was already towards some acquisition like Anite, in order to then have a full portfolio to address 5G and to be first on 5G. And this is what we managed to do by working closely with some key players like Qualcomm. So we did invest in 2016, 2017 to be really the early adopters of the technology in order to provide test solution to the entire ecosystem. Now we are in 2020, we see the commercialization of of 5G and deployment of networks. There's already more than 100 devices available on the market. We see auctions everywhere. I'm based in France, as you can see with my background, with a nice Eiffel Tower over there. In France, the auction just finished. I think the main operator is going to get some spectrum, and they schedule a launch really soon, probably beginning of next year. We see that through all Europe, and I deal just with telecom operators, so I'm really close to all the action with 5G and what's being deployed. What we see, and you will see during the presentation, what are the challenges there when you test 5G, because there's some new features that comes with the standard as the standard evolve. As you can see there, for 5G, it was mainly for three main things: the enhanced mobile broadband, or EMB or EMMB, in order to get broader communication. We saw that with a different generation of wireless, and there's nothing new there. The massive machine type communication, and that's basically the industrial IoT, and to have everything connected. from factories and using actually 5G in order to automate everything to smart cities and even smart homes. And of course, the last but not least, the URLLC, or the ultra reliable and low latency communication, which makes actually a difference compared to the previous generation, as it needs to be a network that needs to reply quickly and be super reliable. We want to have a 99.99999, so 59 at least, after the comma, to have a super reliable network, because some of the verticals, and we will talk about that soon, some of the verticals that are mission critical, or like automotive, you want to have a real reliable network in order to do that. And that's actually push the network operators to make something different compared to what they've done with 4G. Already talked about these threes. Won't spend more time there, but keep that in mind, because as we move with the different releases of the standard, the 3GPP standard, so you got release 15, when 5G actually started. Release 14 was still dedicated to LTE. Release 15 is the first chapter, or the first release of 3GPP for 5G. You will see that depending on the release, you're going to get some aspect of one or another, and then the next release, we improve that, because we learn from the previous release and from the deployment, because this is one of the fastest technologies that's been deployed from kind of proof of concept phase to deployment. I've never seen that in my 20 more year career. I've never seen a standard being deployed so fast and being used so fast after being just a proof of concept. So you will see that it does evolve, and there's more and more coming up with the different releases after release 15. After 15, of course, you've got 16 and 17. So here is just a summary of run 1. So run 1 is the radio access network, chapter 1 of the 3GPP standard, which is basically the radio. It's the RF. I'm not saying the other chapter are not important, but in general, what's drive the other chapter is actually what's going on with the radio, because when they deploy something, it goes through the air, it goes through the RF, through the radio frequencies. So the run 1 will drive the evolution of the standard, and the different releases got different stages. And what you want is being frozen. You want the freeze of the standard, because once the standard is frozen, not only you can let it go, like my daughter thinks a lot when it's frozen, but you can also deploy it because it is stable. It's not evolving anymore. You can basically have a mature standard there and use that to its maximum capacity. Then you can go to the next release. As you can see, there is release 16. And this is where we are right now. The release 16 is about to go through the freeze period in order then to finalize it. And you got that already at the end of 2019. We got a bit of a delay there because of COVID, and I will come back to that. But basically at the mid of 2020, you had the ASN.1 file, which is basically the standard communication file on the network in order to set everything, from chipset to mobile to network. And sets that automatically, and then you can see the run 4 completion at the end of this year. In parallel, of course, you've got release 17. There's been big time delay because of COVID, and we will see that later on. So it's evolving fast, as I said. It's moving fast. Never seen that before for a standard. And basically, it evolved fast for because of several aspects. First, it needed to have LTE there in order to make it happen in some area of the world. So that's why we call that NSA, or non-standalone. And because it started with an anchor being LTE and being kind of similar but better than LTE, it was easier to launch that and to make it evolve. So it's got a lot of strong new requirement and new use cases that we didn't see and that we couldn't do with the previous generation. even if release 15 is frozen and it's like the same for all the other releases, 14, 13, or even up to 99, they keep on being maintained. It's not because it's frozen that it doesn't evolve or it's not maintained. So you need to make sure that when your phone is supposed to support release 15, that maybe some small, but it's going to be just small changes that are being maintained on the previous releases. So that's what's going on right now with release 15 and 16 and the initial work of release 17. So for release 15, we already talked about NSA, NSS, so non-standalone or standalone. So that's if you want a LTE core network, that's non-standalone. It's going to rely on the LTE core network. Or standalone, this is when you're going to move to a 5G core network. EMMB, URLLC, we already talked about that. And then you've got how to make it happen, with carrier aggregation. So this is when you're going to combine several carriers in order to make it happen. And of course, the inter-RAT, the inter-radio access between NR and LTE to make sure everything is working fine. And the stuff that were not like fully deployed or fully developed in release 15 got moved to release 16. So remember when I was talking about massive massing type communication or IIoT or industrial IoT, that's going to be a major update there on the standard for release 16. And then more acronyms, the IAB or integrated access and backhaul, some power saving scenarios for UE that actually is going to help because it can be power depending when you want to do something. The UE positioning, and it's going to be good for handover and actually multi-user when you're going to do some specific feature on the network. The unlicensed spectrum, like we saw in the past with LTE and some others. The V2X, so V2X being the connected car, so vehicle, basically vehicle to everything. In the past, it was vehicle to vehicle, vehicle to network, vehicle or vehicle to infrastructure. Now it's going to be V2 everything. So to have this side link where basically you're going to have communication between even autonomous car talking to each other, like talking mobile to mobile, but of course being autonomous there. Moving to release 17, again, this is some stuff that couldn't happen on 15 and 16 with NTN, so NTN for the non-terrestrial network. So this is when 5G will reach the stars or will reach at least the satellites, and 5G will be relayed by satellites. NR light in order to be a bit lighter on the requirement and to make sure that still we can benefit from some of the advantages, but it's not as demanding as it could be. NR up to 71 gigahertz. Right now we've got FR2, and I will come back to that later on as it is one of the challenge. We've got FR2 going up to 44 gigahertz, but they're going to expand that to 71 gigahertz for what they call FWA or fixed wireless access, and an enhancement, more and more. So release 15 is stable, and this is what we see right now in terms of development and deployment. So the phones that are released on the network right now, on the networks, I should say, the more than 100 devices being released on the network are compliant and test against release 15. Release 16 is stabilizing, so it's not quite stable yet. So we won't do any specific test on that yet because it's not quite finalized yet up to run 4, and there's some delay there due to COVID. And it's even worse than for 17 because it's just started. But it will come. 3GPP is still meeting on a regular basis, even if it's like we do today through Zoom. It's still going on and it's still happening. So quickly on the update and what's going on there because of COVID, all of the meeting actually has been kind of canceled and converting to e-meeting, so there's no more face-to-face. But still, there's a lot of chapter being pushed by key contributor in the ecosystem from the chipset vendors like Qualcomm, or even from Keysight for test and measurement perspective in order to move that through the different RAN meeting, being RAN 1, 2, 3, and 4. Some ad hoc meetings have been added for beginning of next year in order to see what's going on, mainly with release 16 and how we can do that. The ASN.1 standardization was maintained to June 2020. I think they managed to do it. Now we need to roll that out for the deployment and the stabilization of release 16. Rest assured that release 17, even if delayed and shifted by 3 months, is still moving forward and still got a pretty aggressive calendar in order to make this technology step happen. So in summary, basically evolving fast. Keep some key attribute there. Talked about some of the acronyms, the AEMMB, the massive type communication, the ultra reliable network and low latency. It's all kind of the core of 5G, but there's much more. And you will see with NSN, SA what you can do, and we'll talk about some of the capacity of the network to adapt itself real time and do more. Also, a lot of evolution on the infrastructure itself as we're deploying more base station and new base station. It's a new infrastructure. It's NR for new radio, so you need to have new antennas everywhere. So how are we going to deploy that and make it actually happen fast and also being green, because that's one of the motivation of the standard being 3GPP or even NGMN is to have a green network. So less power being consumed or less invasive environment in the environment, and make sure that 5G is friendly with everybody. So there's a lot of initiative there to make it happen. So keep all of that in mind, and then we'll see how we will deploy and you will deploy 5G in your network. So the ecosystem is massive, as you can imagine. There's a lot of company involved there, from chipset vendors. So here you got the 5 key ones, the Qualcomm, the iSilicon, Samsung, MediaTek, and Unisoc. More to come and more actually happening there. Maybe not as well known as, but the drivers are this one in terms of chipsets. Same for devices. I won't name all of them there. You can basically read the different brands and many more. And of course, the test lab, because in order to put that on the network, you need to be compliant. So not only with 3GPP in terms of conformance test, and you will see that later on in the slide, but also with some of the national regulators, frequency agencies, and others. Of course, the operators are part of the ecosystems. And the operators, when they're going to launch that, 5G will be for them not just like 4G. It will bring a lot of additional business in terms of verticals, because once you're going to have this 5G core, so it's going to be more on the SA standalone. When you're going to have the core network being all 5G, you will be able to slice the network and have a specific slice of the network for a specific vertical. Of course, it's going to be expensive for everybody, but this is where the operators will make more money out of the technology, because providing more bandwidth to Joe Smith, me with my mobile, you won't actually be able to charge more than what you charge today. I already got unlimited data for a good price every month. Yes, the quality can be a bit better, but I won't be able to double or triple my monthly bill for my phone. This is not the way they're going to make money. The way they're going to make money is by addressing some new verticals that they couldn't do in the past. And I already mentioned some of them, like automotive, when you're going to have autonomous driving, and even the steps to go from a car today to the fully automated one, or autonomous one, sorry. There's some steps in between where you can dedicate some slice of the network to make that happen and to make that safe. So at the beginning, CV2X, so connected vehicle to everything will happen, but will come on top of all the great technology you got on the car already, like the anti-collision radar and more. But you're going to have that coming with then 5G with more monitoring and better management of the traffic, for instance, in order to avoid traffic or in order to have good emergency call and so on. Aerospace and defense is also looking at 5G. So I already talked about the the NTN with release 17, the non-terrestrial network. As you're going to touch satellite, some people will have some interest of 5G with a satellite. Industrial IoT, of course, this is when you're going to have manufacturing line using 5G to automate some of them. And some of the test cases and use cases and pilots have been done for manufacturing using 5G, automating full production line with robots being driven by 5G, and many others. And you will see that in the next slides. Because, for instance, for EU, European Community, European Union, this is actually the 5 top verticals. So media, of course, everything you can get with more broadband. So that's going to be your 4K, your 8K and more. Then transport and automotive. That's going to rely on some of the aspect of 5G, of course, the reliable network, but also the broadband, because you need to have some of the access there of the bandwidth in order to make that happen. The Industry 4.0, so that's what I was talking about with industrial IoT and more, because that's what you need to deploy in order to have everything automated with 5G, and healthcare being one of the vertical that I didn't mention before. But when you're going to have your e-doctor or e-surgery, I hope it won't be the killer application, but the e-everything. But because you're going to have a better 5G network, you will be able to do more because it's going to be wider, better, faster. So we couldn't do that with 2, 3, and 4. We can do that with 5. Of course, the frequency coverage will have some interest and will be super important there. So depending on the country, depending on what you're going to bid for in terms of frequencies, you're going to get different coverage and different throughput. Super high coverage at lower frequency and lower coverage, like maybe a kilometer, when you're going to go FR2 or 24 and beyond, gigahertz that is. But the throughput then would be really high at 24 gigahertz when it won't be that high on smaller bandwidth, basically at a lower frequency. And all these verticals will have, oops, what happened there? I lost control. Oh, here it is. Of the different verticals, so everything connected. So some of them there are, I already talked about that, like the one in red. The one maybe I didn't mention that much are the green ones, but there's a lot of things there. Just going to take one example because I did work with a telecom operator in a Nordic country. Actually, a farmer farming industry came to the telecom operator and asked them to have a slice of the network dedicated to them to have 4K or even higher resolution video camera on their salmon farming, because there's lice, basically, parasite that can destroy a full salmon farm just because it's there. So they want to have a monitoring 24/7 with detection on high resolution camera of a lice, because it's a small organism that can pollute water where salmon is being farmed. And they want to pay millions of euros in order to have that, because if actually a lice comes into the pond where the salmon is, that can destroy the full farming industry for a year at least for them, and they're gonna then waste billions of dollars or euros. So that's why they're ready to pay millions of euros in order to have this 5G monitoring, which is a vertical that didn't exist with 2G and 4G, when salmon actually did exist at that time, for sure. But the monitoring of fine 4K IoT technology on the farm is something that can be really a vertical for 5G. And it's just one example among many. So here in terms of complexity, you got NSA, non-standalone, SA, standalone, TDD and FDD, and you got many other aspects. You've got MIMO, multi-user MIMO, beamforming, active antenna, EMF, which is the electromagnetic field, and what people can be worried about with more waves coming around you, and is it okay or not? Massive MIMO, of course, massive IoT or just IoT. Release 16, we already talked about it. Cloud, everything going to the cloud, and we'll talk about that today too. Edge computing, network slicing, already talked about that with the SA implementation. Virtualization, when basically you don't really need a a hard network. You can have a soft network just with some hard element for the radio, but everything then is virtualized and in the cloud. NTN for the non-terrestrial network. The unlicensed NR, of course, coming up. And what we're going to talk about today, DSS, or the dynamic spectrum sharing, which is something that goes with LTE because we rely on an LTE network. Why not using the resources of LTE and deploy 5G straight away? ORAN, or the open source radio access network, going to talk about that today, and FR2 millimeter wave. So in the next half hour or so, I will cover these topics and how actually Keysight technology contribute to all of that and be able to provide solution to test these challenges. As you can see, there's way more. And of course, there's some proof of concept project with many consortium groups, working groups like 5G Vini, 5G Genesis, 5G Eve. We do participate to that. Keysight technology do have some participation into these end-to-end infrastructure pilots. And of course, by participating to these working groups, we can then provide some test solution for what needs to be tested. And now we're going to cover these 4 yellow parts being DSS, ORAN, and FR2. So DSS, it's a good potential approach. So dynamic spectrum sharing, we basically going to have a dynamic allocation of resources on a spectrum that is allocated to LTE, and we're going to share that between LTE and 5G. So some people actually are using that today in order to kind of play with 5G. Yes, they're going to get some frequencies, they're going to get some bandwidth for 5G, but maybe not the spectrum they wanted because, you know, not enough available spectrum there. But they got the LTE network. And maybe they don't use the LTE network as much as they could. In the past, remember with LTE, we had these multi-broadcast dedicated resources that basically were never used that much. So there's all this spectrum that is not used at LTE. Why not using that? So the 3GPP standard put something there in order to make that happen, and it's called DSS. It's got the advantages of adapting the traffic demand. So if actually you don't use LTE that much and you want to use more 5G, then that's the way to adapt the demand with what you've got available on your network. The problem is by doing that is you're going to reduce the total capacity. So again, release 15 of DSS will work, but you will see in the next few slides that it's not that efficient. And yes, it can make some telecom operator happy, or at the end of the day, the end user happy, because he will see the little 5G logo on his phone activated because you're going to use 5G on the LTE network. But for the overall capacity and efficiency of the network, it's not a good thing. So it will evolve from release 15 to 16 with some enhancement on DSS also on release 16. So the way you can do that, and going quickly there, is reforming what you've got on the LTE bands and use 5G on some LTE bands. So it's kind of, you know, when you reform some frequencies, in the past, when you reform frequencies, you waited for the technology to die, and then you reform the frequency available by using this now available frequency with a new technology. Now what we do there is using the LTE band and the LTE that is still alive with 5G at the same time. So it's kind of cheaper because you don't have to deploy a new full network there. Like you've got already the LTE resources there. Still, you're going to have the antenna for 5G, but it's kind of cheap on the base station that you've got for 5G because it's just a software upgrade. It was pushed by Ericsson at the beginning. Nokia is following, and the other two, in order to provide DSS on the network. But to have DSS available, you need to have that on the base station, of course, and on the mobile. It's not because you've got that it's going to work automatically. And of course, it can only happen if it doesn't disturb LTE. As soon as it's going to disturb LTE, and this is a threshold also that the operator is going to have to put, as soon as it's going to be not that efficient and not that even efficient as LTE itself, probably then it won't be used. So that's why you need to test, and that's why Keysight technology can help you testing DSS on a given network. Because the flexibility on the implementation, basically what you take in a nutshell is what you got available for LTE, and whatever holes you've got there for data, you're going to plug that with some 5G data. High flexibility, but really demanding on the scheduling of the data, really demanding on what needs to happen there. So there's some proprietary implementation there. If you talk to Ericsson or Nokia or even Huawei or the others, they will have different approaches there. And also it will depend on what the phone can handle and what the phone can support. So that's why we need, as Keysight Technology, to be able to provide you some test equipment to make sure that when or if you want to deploy DSS, it's going to work with the element you're going to put on the network. So here, quickly, as I said, if you use the same carrier spacing as LTE, so if NR is using the same carrier spacing of 15 kilohertz, then it's easy. You just fill the blank here with your NR carriers. That's easy. If you don't have the same carrier spacing, in order not to disturb that, you're going to still leave a blank there for the guard band in order to make sure that the LTE, being here in green, won't be disturbed by the NR, which is here in yellow. So that's one way of approaching that in the downlink. The other one is using this multi-broadcast SFN subframe that are not used really by LTE, and they are blank, and you can just plug your NR data there. So it's available, not that much, but again, you can use that, and depending on the carrier spacing, again, you got the guard band or not. So you basically need to make sure the LTE map that you got here in the top corner will be okay with the NR you want to plug in. As soon as it's going to disturb it, it will create a traffic jam, clog, or actually it won't work because you will disturb LTE, because the goal of DSS is not to disturb LTE. As soon as you're going to disturb LTE, it won't be done. So that's why in some of the regions, you're going to have to be careful with what you do with the NR transmission, with some of the numerology you're going to use for NR and the way you're going to implement that. Same on the uplink, a bit easier, but then basically here you use the same guard band or shift in terms of frequency in order to make sure you don't disturb NR. In terms of test, and this is the problem that we see with DSS, and I will show you then some of the tests we've done with NEMO, which is our drive test solution, is the impact on the NR or moreover the LTE capacity. And for the NR capacity, you're going to have tens of % of downlink overhead, which means you're going to suppress some of the great capacity of NR you could have if you just use NR and you just leave NR alone, or you just leave LTE alone. So this overhead will be a problem on the network as you're going to reduce the capacity and the efficiency. Do you want to have that? In some cases, yes, because again, it can be just a marketing thing or 5G launch and it's done and actually it doesn't impact that much. So yes, you've got some overhead, but you're still going to manage that. But then when the overhead is going to grow and it won't be sustainable anymore, maybe you want to wait or for the enhancement of DSS implementation by the network equipment manufacturer supplier, or by the standard with another implementation of DSS with what Release 16, for instance, will bring. For the UE, so it's a network thing, right? So Nokia, yes, or Ericsson just going to upgrade the software on their radio and boom, you're going to have then DSS enabled. For the phone, it's also a thing. You need to have an LTE phone that can support DSS, and not all of them will do that. Again, it needs to be transparent for LTE. So it's going to have some signaling capability on the NR side in order to make sure you respect the scheduling, not to disturb LTE. So let's see some of the tests that we've done a couple of months ago when DSS was launched. And I think we've done that on an Ericsson network. But again, it will be the same. It's just to show the reality of DSS in the field and the spectral efficiency. with the back and forth handover, or here when you do the DSS, and of course the quality of services you can get when you deal with the voice. So for that, we used Nemo Outdoor, so which is our platform for drive test. If you want more information about that, I'm sure Pános would be more than happy to provide that to you. Some devices, LTE devices, 5G NSA devices, where you can actually do that, where you can do the DSS. And then, of course, if you want to monitor that, we've got different way of doing that, and we can do that with Nemo Walker Air, for instance, depending on the way you want to monitor that and see what's going on the drive test solution. So we've got different test methodology there, but the main purpose there is to see if NR DSS works or not. See some of the test configuration we've done. So here we took the same numerology of 15 kilohertz, and this is where we put the when we use the NBSFN. So the network was basically taking the blocks not used by multi-broadcast in LTE and then put some NR there. So as you can see there, for the throughput, worked pretty well. You've got the 5G plus LTE, so 81 plus 80, go to 160 megabit per second. So here it was okay, and the data transfer was okay, and no bandwidth bottleneck there for the air interface. Then you started to see actually some evolution there on the data when you start to do the DSS test, and then when you were on 5G only at 140 megabit per second, LTE plus 5G, that was 160 megabit per second. So kind of here reducing here the 5G capacity of, from 140 to 80, and then LTE only was not tested. But already there you see some of the overhead that maybe was not as good as when you were using just one technology. Done that with some other tests there. And in summary, without enabling DSS, we had the maximum throughput of, let's say, 226 megabit per second with 5G and 195 megabit per second with LTE. And you can see actually the overhead and the way it was reduced there when you use just one technology or another, and then when you put DSS. So it's really important to make sure that when you deploy that, you're okay with the overhead that's going to create, you're okay with maybe the reduced capacity you're going to have on one technology or the other, and it's fine if you can live with it, but it's something to consider, and maybe a different implementation can be good for the network. So in summary, for DSS, we got great tools there. It needs to be backward compatible with LTE devices. A lot of solution available on the KeySat portfolio can help you to do that. Of course, the 5G network emulator. So the reason why you want to have that is maybe because your Nokia base station or Ericsson base station is not DSS enabled yet. So you want to have a network emulator. You want to emulate, a G-Node B that has DSS capability to test the mobile that you just got that's supposed to be DSS. Well, we can provide you a network emulator to do that. Can do also the other way around, where we have a UE sim or a UE simulator, a UE emulator, in order to emulate LTE and NR devices in the DSS test cases. And then you can do that in the lab, basically to see if, of course, it delivers what it wants, and see here the overhead and the efficiency of the network you're going to have. And then last but not least, I already talked about that with some of the results you saw on the slides with the Nemo solution, which is our drive test solution, where you can do the end-to-end testing on real device, on a real network. So not in the lab here, you just stay outside and see what's going on there and see if it's working well or not. And many other solutions. But this is kind of the three solutions there for DSS. Moving on to ORAN, this is really here open source, and how we can help the entire ecosystem to reduce the price on the radio access network. This is the main goal. It's how we can make things interoperable because it won't be just one supplier. In the past, or what you can see there, you had everything provided by one supplier. You had the radio unit, the front hall, and the baseband unit provided by, let's say, Nokia or Ericsson. Again, I just take that as an example. I don't have any stock option or interest of mentioning that. This company is just the way it was. Nokia or Ericsson will provide everything there. The baseband unit, the radio unit, and sometimes the radio unit was not performing as well, so there was a little tweak on the baseband unit to make sure it's going to perform better, or the other way around, and then that was connected to the core. And you had the front hall there that was between the baseband unit and the radio unit. So that in the past, this is what happened, and it was one single vendor. So in the past, the operator had to pay a lot of money in order to have that by just one supplier for some of their sites. And it was always everything from Ericsson, or everything from Nokia, or everything from Huawei, ZTE, you name it. ORAN came in order to have that open source, in order for you to have maybe a radio unit coming from Nokia, a baseband unit coming from Huawei, and so on. But again, here, it needs to be interoperable. Like they cannot be proprietary between the units, because if it's proprietary, it's not common, it's not open source, then you're going to have problem of interoperability. So Open RAN, in order to make sure that maybe you get the best RU or radio unit on the market and the best CU, centralized unit on the market, or the one you think is the best, then it needs to be interoperable between the different units. And for that, this is what you've got with ORAN. And basically, disaggregate the network in order not to have everything from one single supplier, but just basically a radio unit. And the rest will be more or less cloudified, will be open to some other supplier in order to provide a solution that is, at the end of the day, cheaper. But it's not just only to be cheaper, but also to be, let's say, better for the network and everybody compared to what was deployed in the past. So in the past, we're talking about backhaul, front haul, even X-haul. Now it's basically the backhaul became the front haul, and you're going to have different elements. So you're going to have the RU or radio unit. You're going to have the DU, distributed unit, or CU, centralized unit. And that would be the three main elements together with the RIC. This RAN intelligent controller, of course, in order to control that real time or near real time, as I say here, to have your disaggregated network with element coming from different supplier. So it's pretty cool to play with that. We are actually a member of the ORAN Alliance. It's like 3GPP, but it's for RAN. It's actually work aligned together with 3GPP, and one needs to be deployed. Like, for instance, when I was talking about RAN 1, it needs to be there, of course, and make sure that everything works there too. So we are a contributing member and editor of the conformance test specification for ORAN in the working group 4. There's 9 working group. And for the moment, there's more than 20 operators in this alliance and more than 130 manufacturers, suppliers there too. And basically here, it's really to have this multi-vendor interoperable autonomous RAN where you'll be able to plug and play different elements and make life easier basically for everybody for a better quality of services at the end of the day for the end user. That's why for the test cases, you're going to have emulation, and that's where they are right now. Conformance test, we are, as I said, reporting the test cases and the conformance test cases for the standard there, and then analyze what's going on there when you're going to virtualize everything, when you're going to have that in the cloud, when you're going to have emulator of everything, when you're going to have your RIC, this intelligent, remember there, the RIC, your intelligent controller there that makes sure that everything will work smoothly. So we need to be able to test all these elements, and rest assured that, of course, Keysight will provide solution for that in the entire ecosystem here for ORAN. So I was talking about the RU, and now it's going to be the Open Radio Unit, the ORU, or the DU, the Distribute Unit, when you go from the front through the frontal to the distributed unit, and then to the central unit, to the backhaul, and then to the core. So because all these elements now won't come from one single supplier, but several, a myriad of them, you need to make sure that all of these little boxes can talk to each other and in a common language, not proprietary, not using CPRI like in the past. CPRI was supposed to be a common interface, and actually there was an implementation per supplier, and it was not common at all. So now we try to get rid of that and make sure they can talk to each other. So for that, we have solution on the radio, of course. This is one of our core business within Keysight. Of course, also on the UE emulation, because we did acquire a company called Prisma, and now we can do that for the UE emulation. And of course, on the core simulation, we can do that too, because we did acquire a company called Ixia. So Keysight now is basically a one-stop shop in order to test all these elements and emulate whatever side of the RU, DU, or CU you want to test, including the RIC, which is something that right now a lot of the operators are looking at, because the RIC will be the one that will be in the cloud and controlling all this new open environment. So we got solution for that, and going from, of course, the lab to the field. So you will find, again, here some drive test solution for that. You will find some network emulation for that, when I was talking about testing the phone. But also, of course, when you go more to the right, when you're going to go more to the core network and how you're going to load the core. So that's with Xload, when you're going to look at the core network and core load, how you can do that there to make sure that everything will work. And we can basically emulate anything. And that's one of the reasons why it's good to have a one-stop shop there, because not only we are contributing member of the ORAN Alliance, but also we have solution for every step through the ORAN architecture there and the cloudification of this network. In the interest of time now, I'm going to move to FR2. You will see this slide anyway. I will send you the slide, and you will have this reference material. So do not hesitate also to come back to Pános or to me if you've got more questions around ORAN. But again, ORAN, as we open the radio access network to any supplier that can provide one element of the network, it makes it a bit more complex, but because of these standardized interfaces, it will work, and we will make sure that it will work with the solution that we will provide. Now, to finish my presentation today, I will talk about FR2. So FR2 for frequency range 2. Remember, LTE, NR, NSA, SA, that can operate at FR1, so sub 6 gigahertz. But there was this FWA that I talked about earlier, this fixed wireless access, which is something that will provide you a way wider bandwidth. We're talking about 200 megahertz bandwidth or even wider, but at millimeter wave. So remember, the coverage was not that great. The throughput was outstanding, but the coverage will be just a kilometer. And it's really subject to the channel condition and the environment. So it will suffer from fog. It will suffer from something coming in between. Like if it's a tree or something, it will suffer from that. So it's not really resistant in terms of channel condition, but it's going to be a really good wideband access, a fixed wideband access for everybody. So it can be complementary to wireless LAN, of course, and Wi-Fi. It would be complementary to Wi-Fi 6 and Wi-Fi 7 coming, or it will be actually the way to get broadband wireless access at home where you don't have Wi-Fi. And because it's FR2 and because it's going to go to 24 gigahertz, 44 gigahertz, and in release 17, remember 71 gigahertz, we cannot go cable there. It needs to be over the air. It needs to be OTA. And for that, the solution that we provide needs to be in a chamber. So the magic will happen in a chamber. And we have the full portfolio for that. So again, Keysight will provide the complete solution, end-to-end solution for this FR2 UE validation test. Now I got a phone. I got a phone that is FR2 that works at millimeter wave, and I need to test it. I need to test it with all the great stuff from 5G that I talked about earlier, not only FR1, 6 gigahertz, but now FR2, and with all the technical complexity I was talking about earlier, going from maybe doing some mobility scenario, moving from FR1 to FR2, even beamforming, massive MIMO, and so on. And that with still a great maximum throughput that is better than the previous technology. Otherwise, if it doesn't bring anything to the table, why people would invest in FR2? So for that, of course, there's development, acceptance, manufacturing, and deployment. And we've got the solution for all of that. I already talked about the network emulator. So this is the box you can see here on the left. We'll talk about that a little bit in a couple of slides. And then because you're going to have to go into a chamber, because it's FR2, you don't have a cable at these frequencies. It's going to have to be over the air. You need to have a chamber in order to have an environment when you can perform a reliable, calibrated test. So we have a network emulator. So that's kind of the core solution there. So it works for FR1. If you just don't work on FR2 yet and you just still sub 6 gig, use just this box. You don't need a chamber. You can be cabled or you can use antenna pads. You don't need FR2. So this box works NSA in one single box, provide the LTE anchor or can be LTE standalone with mobility scenario and fallback scenarios to 3G with CV2X. So here we got a full network on the bench. You don't need to use a G-Node B. This is your G-Node B emulator, and it's way better than a G-Node B that you're going to get from Nokia, Ericsson, or Huawei because it's got all the features enabled already, DSS being one of them, and everything from 3GPP because it's 3GPP compliant with all the functionality that your network can have. So to test your device, this is definitely what you want, and this is what telecom network operators are buying today because they want to validate the tens of phones that they got on their desk before they deploy that on a network. And we've got different software for that and multiple domain, multiple capabilities that you can do on the box. So depending on who you are and what you want to do, and you can see that here on the table, you can just test the protocol and or just RF and or some of the KPIs or key performance indicator that you want to do on the phone or on the network. And of course, for manufacturing, you won't use the signaling, but you got also a solution for that. So we've got really a full set there on this box that is just sub 6 gig. And depending on who you are, so for the telecom operators, you can see there, you got an application that will meet your requirement in terms of test. So that's for sub 6 gig, but also FR2. So to move to FR2, in order to do that, because it's a sub 6 gig box, you can invest in that today, sub 6 gigahertz. And then when you move to FR2, it's just a little upgrade of an additional box to go from 6 gigahertz to 12. And then the millimeter head that goes from 24.25 gigahertz to 43.5 gigahertz, which are the release 15 and 16 FR2 bands that are covered today, just with one RH for the coverage from 24 to 44 gigahertz, basically. So that's what you can do, and that's the building blocks to do that. And as I said earlier, because you need to go OTA, you're going to need a chamber. So depending on what you want to do, it's going to be a direct far-field chamber or indirect far-field chamber, depending on the need you have. So indirect far-field chamber will be just one angle of arrival, which is kind of forced here with the mirror, like all the waves will kind of converge into a mirror and then go on the phone. Or you can have the direct far-field, and here you'll be able to have several angle of arrival, as you will see on these slides. So it's not one chamber fits all the needs for test. When you're going to go FR2, and this is also the complexity there coming with 5G, depending on what you want to do, you will need a chamber for what you want to do. And we see some MNOs, mobile network operators, that will have more than one chamber there because not only they want to do RF performance, and here in terms of RF performance, you may be familiar with the term or acronym PRT or, PRT. TRP, total radiated power. Put it the other way around, sorry about that. TRP, total radiated power, or TIS, total isotropic sensitivity. So that's when you want to have RF performance and power test, one angle of arrival. But then if you want to do mobility, then you need multiple angle of arrival and not just on one plane, which will be just 2D. So that's why here we've got the two-dimensional. So here just several angle of arrival, but just on one plane, or several angle of arrival, but in 3D on a sphere in order to do that. So depending on what you want to do in terms of test, you will need a different chamber, and that's defined not by Keysight, it's defined by the 3GPP committee on the methodology to make sure that what you test is real compared to what's going to happen in reality. So that's the chambers, and again, all of these are available through Keysight and will help you to overcome the test challenge of 5G NR with FR2 frequencies with millimeter wave. So that's kind of what I got today for you guys. Just rest assured that in the ecosystem, to wrap up my presentation, you saw that with 5G, there's a lot of things there going on. We have the expertise to help you not only to come up to speed there on the standard, but probably you are already up to speed there in what you want to do, but more up to speed on the solution you want to invest in. And here, come to see us to see what you want really to focus on, because you saw the technical complexity of 5G. And depending where you are at in terms of workflow for your network device and infrastructure, we can help you there to test whatever you want for 5G. Just come to us, we can test it all. And as you can see there, remember these 5 verticals? Here, we can test it all. We got a solution for everything. We got a solution for the acceptance test for the operators. We got a solution for the automotive. Remember when I was talking about autonomous car, we can emulate that. It's not a problem. Talked about FR2. We got the full solution there for FR2. So don't be scared about millimeter wave, OTA. We got that covered. Virtual drive test, so you can combine what you do outside with your drive test solution and bring that back into the lab and play that back. Didn't have time to talk about this solution, but it's really key to benchmark some mobiles. You just can have a sequence there, a drive that you're going to play back in the lab, and always the same drive, and then you can test one mobile after another. You don't have to drive anymore except for this reference drive. I didn't talk about that, but when you move to the cloud and when you need to test some of the interface there with 400G, we can do that. We got it all. So don't worry about 5G. Yes, there's some technical complexities, there's some challenges, but as you can see there, Keysight Technology is involved in the entire ecosystem, and wherever you're at in the ecosystem, we will have a solution for you. We did invest in 5G by doing some key acquisition through the years from the beginning of 5G to make sure that we are the first test and measurement company to help you deploy and use 5G in the best way, to make sure that your investment is protected, and to make sure at the end of the day, if you're a network operator, your customer will be happy and will have a great experience using your 5G network. So that's it from my slide. Thank you very much for your time. Do not hesitate to come back to me if you've got any questions, and to go on our website, keysight.com/find/5G, to get more materials and more information about our solution.
Thank you very much, Renaud. All the things that we hear from you were very interesting. I have a question, both of you, about especially your targets in Greece. About vertical markets in Greece, what is your targets generally?
In terms of customer or in terms of verticals?
Both of them.
So in terms of customers, we can address them all. So for instance, when I look at, and I just look at the people you've got there, like some of your sponsors, I assume, for this event, so participant there, of course, Cosmote would be, of course, the ideal customer there because, you know, in order to deploy the proper network and have the proper capacity and capability on the network, a lot of things needs to be tested, and we can test it all. So it's great. But I see Schneider there, same. It's whatever vertical they want to address there. So based on the network that Cosmote will deploy, and I just take Cosmote because I see them there, but it can be any other network operator. Based on what they're going to deploy there, then Schneider maybe will use a slice of the network that Cosmote deployed. And then Schneider will come to us and say, oh, I got this slice, I got this operation, I got this, I want to do full automation of this production line there with the Cosmote network. Can you help us to make sure that it works properly and troubleshoot what's going on there? And then, of course, with Ericsson or Lenovo or even Vodafone there, so Vodafone, of course, network operators, same test or use cases as Cosmote, but with Lenovo, it's going to be on the UE side or on the whatever device you're going to put on the network. And Ericsson, yes, with the base station, make sure DSS works properly. So even if an Ericsson base station is deploying in Athens, let's go there and measure that it's working properly. And we use field test, or if a base station from Ericsson is in Cosmote lab, let's test it and make sure it works properly before deploying it. So for that, everywhere. For the verticals, it depends on the vertical that will be available on the network. And we can test them all. It's just a matter of the functionality of 5G you want to use.
Okay. Για να κλείσουμε, Παναγιώτη, θέλεις να πεις κάτι?
Ναι, αυτό που θέλω να προσθέσω εγώ είναι ότι η Keysight και η Vector και η Nemo Technologies, με το προϊόν της Nemo Technologies, είμαστε εδώ και ήδη εδώ και ένα χρόνο και τα πρώτα πιλωτικά που έχουν γίνει στους operators στην Ελλάδα, για να μην ονομάσω συγκεκριμένα, γιατί όλοι οι operator είναι πελάτες μας, άλλοι μικρότεροι, άλλοι μεγαλύτεροι, όλα τα πιλωτικά έχουν γίνει και έχουν μετρηθεί με εξοπλισμό της Nemo Technologies, της Keysight Nemo. Εδώ και ένα χρόνο, δηλαδή όταν ακόμα ήμασταν σε επίπεδο lab, ήδη έχουν βγει στο πεδίο, ήδη έχουν γίνει μετρήσεις και είμαστε πρωτοπόροι, ήδη έχουμε μετρήσει DSS. Παρόλο που είναι πάρα πολύ δύσκολο να δικτυώσεις ένα τηλέφωνο σήμερα, γιατί είτε στο Volte είτε στο DSS, μάλλον όπως και στο Volte είτε και στο DSS, στο 5G, ο κάθε operator έχει το δικό του firmware. Δεν είναι το κάθε κινητό τηλέφωνο εύκολο να συνδεθεί σε οποιοδήποτε δίκτυο. Απαιτούνται ώρες δουλειάς και από τους τεχνικούς αλλά και από τους κατασκευαστές κινητών τηλεφώνων για να καταφέρει να δικτυωθεί. Πόσο μάλλον να μετρήσει. Αυτό το έχουμε καταφέρει ήδη και ήδη μετράμε δίκτυα 5G στην Ελλάδα και στη Ρουμανία.
Πολύ ωραία. Θα ήθελα να σας ευχαριστήσω και τους δύο. I want to thank you both, Renaud and Πάνος, for all your support.